Welcome to Study Loop.
This is the answer to Chapter 23, problem number 53 from the Smith Organic Chemistry textbook. This problem asks us to draw the products formed, including stereoisomers in each reaction. Okay, and so in A, we have a ketone, so we're going to deprotonate the alpha carbon of the ketone. And in this case, the alkyl chloride can then add from either side. And so we are going to form a mixture of enantiomers here. So we should get an equal mixture of each of these two enantiomers. Okay. Part B is kind of a trick question. So there's stereochemistry in the alkyl halide that we're using, but doing this reaction does not induce a new stereocenter. And so we're only going to get a single enantiomer here. We're not going to get a mixture, which I guess might be what you would expect at first look. And so what we're actually going to get is this. Okay, and that's it. No other enantiomer, as I said. And the case is the same for part C here. We're not inducing a new stereocenter. We're actually doing a reaction, far away from the existing stereocenter, and we're not inducing a new one. And so there's not going to be any stereochemistry to account for here other than maintaining the stereochemistry that's present in the starting molecule. Okay, so A is a mixture of enantiomers, and B and C are not, and they're kind of almost like trick questions because there's either chirality in the alkyl halide in B or chirality in the starting material in C, but it's important to not sort of fall for that and to remember that since we're not inducing a new stereocenter or doing a reaction on really an existing stereocenter, that nothing's going to change there, and we're going to get back stereochemistry that reflects the stereochemistry of our starting materials. And that is the answer to chapter 23, problem number 53.